Hello, and welcome to Grade 3, Unit 5 Preview or Overview. This unit's talking about measurements and fractions. Have your note sheet ready and your notebook to take some good notes. Pause the video at any time if you need some extra explanation about it or extra practice. Otherwise, here we go. The first topic we're going to talk about is area and perimeter. Now, we've talked about this in previous units, so it shouldn't be a new concept. However, it is one that takes some extra practice and some reminders about different key aspects of it. The first thing is area. Area, remember, I like to use the term base times height. You'll hear length times width. But as you get into shapes of different types of polygons, different types of quadrilaterals, you're going to be using the equation base and height. Now remember, base is what the shape is resting on. Height is 90 degrees from the base. So we multiply those together. We are finding the inside amount of this space. And because it is a base and a height, that means it's two dimensions that we're looking at. So our label needs to be squared. So it could be squared units, squared feet, squared inches, squared miles, any type of square, but it always has to have that squared because we multiplied one dimension by a second dimension. The next one is perimeter. Perimeter is the outside measurements of a shape. Now, this would be like putting up a fence around an object. Yes, we are going around multiple different sides, but we are walking in a straight line and we're only covering the space of the straight line, which makes this a one-dimensional object or item. So we just do our side plus side plus side plus side. And our label is going to be units. So it could just be feet, just inches, miles, meters, whatever measurement might be used. Let's take a look at an example. Now these ones are getting a little step harder than the first couple units where we saw this information. And so if we take a look at our first example here, we know, so we can write down some of our known information. We know 28, and we know the 7. Now, if we look at this, it says that it's 28 squared inches. So that means this is our total. And it says 7 inches, so that means this is a part. And our question mark of our other known would be our other missing part. Now, if we have a total and a part, we know that we are going to be dividing or we are going to be subtracting based on what type of problem it is. So in this case, it's talking about squared inches, which means that this is the area. And in order to find the area, we needed to do base times height. So if we used multiplication to get to the area, we're going to use division to get to a missing side length. So our equation is going to be 28 divided by 7 to get us what our missing amount is. And we find out that our missing amount is 4. And because it's only one of the side lengths, the label will be just inches. On the bottom one here, they give us a side length, so our knowns. We know 6 is a side length, and we know it says perimeter is 20 inches. So we have a total of 20, and we have a part of 6. So we're missing our other part. Now, this one's going to be a little different because it's perimeter. Perimeter means that we are adding all the outside measurements. Now, if we know that this one is 6, then the opposite side is also 6 inches. If I add 6 plus 6, I get 12. So I'm going to take my 20, I'm going to subtract out the 12 that I already have, and I am going to find out that I have 8 remaining. But I have that 8 that needs to cover in 2 spots. So I'm going to take the 8 and I'm going to divide it by 2 since I have 2 missing numbers still. And I'm going to find out that I have 4 on both sides. Now I can double check my work. 6 plus a 4 is 10, and another 10 makes 20. So I know my missing side length is 4. And what measurement did we use? We used inches. So it would be 4 inches. Ooh, my writing's difficult there. All right, moving on. Our next topic is going to be where it's new for this unit. This is area of complex rectangles. Now, we know how to find the area of a rectangle. This is just adding multiple rectangles together. So your very first step to do is to walk around the shape and find any of your missing side lengths. So I see I have a missing length here and I have a missing length here. So I need to find out how much each of those are. Now, if I look at this whole side length right here, I know that that's my total amount of the height of my shape, which is 11. I see right here I have a part of it, which is 4, and I am missing the other height part of it. So I can do 11 minus 4, and I find out that I get a missing amount of 7 centimeters right here. Now, we can take a look at the tops and the bottoms. If I look at the bottom of my shape, it says 7 centimeters across the whole shape. The top has a 2 centimeters and a missing centimeters. So my total amount is 7. I already have a 2, so my missing amount there is going to be 5 centimeters. So that's the very first step you want to do. So that as you walk around the shape, all of your side amounts are there. That's going to help if you have to find the perimeter of the shape, which you will have to do in this unit also. Then the next thing you're going to do is divide the shape. It does not matter if you divide the shape across right here or up and down right here. I like to do horizontal lines. It's kind of just a preference. It doesn't really matter. What matters is what maybe would make it easiest for you. Now, notice, we just cut into this line right here. So I do not want to use the 11 as one of my numbers. So if I do base times height, I have a 2 across the top and a height of 7, not the 11, because the 11 would have went past where I just drew my line. And 2 times 7 is 14. I like to write my answers right within the box and then circle the answer I get so that I know how I got to that answer. The next one, if we go around the shape, we see multiple numbers. There's the 11 again, a 7, a 4, a 5. So as we walk around the shape, we want to see where it's the entire line measurement. So I see a 7 and I see the height of 4. So I'm going to do 7 times 4, which gets me an answer of 28. Now, the 14 and the 28 are what's called a partial product. It is a part of our answer. It's not the complete answer yet. What we need to do last is add those two numbers together. So we're going to take the 28, we're going to add the 14, and we're going to find out what our answer is of 42. Now, 42 is not my answer completely yet. I need to have a label on this. So I see that it's centimeters and I know it's area. So I need to square my label. So cm is the abbreviation for centimeters. And I can put my little exponent 2, which means squared. I could also write this as SQ dot cm, or I could have written out completely squared and then the word centimeters. This way right here is one of your fastest methods that you can do. Moving on to our next topic. It is talking about equivalent fractions. Now, we talked about this a little bit in the last unit, but let's really dive deep into it. Remember, the top number is your numerator, and that is your part. The bottom number is the denominator, and that is the whole amount of your object, how many pieces it's broken into. Now, if we want to be equivalent, we want to do the same thing to the top and the bottom. If we multiplied the top by 2, we better be multiplying the bottom by 2. If we don't multiply them both by the same amount, we are not going to end up with an equivalent fraction. So right here, I had 2/3. I multiplied the top by 2 and the bottom by 2, and I now get 4/6. If we look at our drawings, you can see that 2/3 and 4/6 is the same amount of the circle shaded. I can take my 4/6 and times those by 2 and get 8/12. If I draw that out, you'll see again that 8/12 is the same thing as 2/3. Let's take a look at two different kinds of examples. So the first example is if I have a fraction on one side and then I only have a part of a fraction on the other side. I need to find out how I went from one to the other. So how did I get from 7 to 35? 7 times 5 gets me to 35. What I do to the top, I do to the bottom. So 9 times 5 is going to get me my equivalent fraction amount of 45. Now, the other one that you might see is a equivalency chain, just like this bottom one. So I need to figure out how I get from one to the next. Now, I like to always go back to my start fraction. So how do I get from 3 to 12? That would be times 4. What I do to the bottom, I do to the top. 1 times 4 is 4. So my missing amount there is 4. Now, going from 4 to 3, that's really tricky. So again, that's why we're going to go back to the start. How do I go from 1 to 3? 1 times 3 gets me to 3. So what I do to the top, I do to the bottom. 3 times 3 is 9. And then the last one, again, we're going to start at the front and go all the way to the 24. 3 times what is 24? 3 times 8. You are always multiplying when you're doing equivalent fractions. So 3 times 8 is 24. What we do to the bottom, we do to the top. 1 times 8 is 8. All right, moving on. Equivalent fractions can also be written on a number line. When you're making equivalent fractions on a number line, it is important to use a ruler. If we have from 0 to 1 and we want to break it into 4 equal parts, we're going to want to make sure we measure the space between the 0 and the 1 and divide it out into even amounts. That's going to help us when we're trying to find equivalent fractions, like right here. An equivalent fraction is 1/2 is equal to 2/4. Another equivalent fraction we might see would be right here. Now, we don't see the fraction parts. This one would have said 2 over 2, and this one would have said 4 over 4, both of those making 1 whole. So another equivalent fraction would be 4/4 is equal to 2/4, or 2 over 2. All right, our next part is working on money. So switching gears here a little bit. And the biggest part we're going to do for money is making change. Now, I have a very big pet peeve. My pet peeve is when people put the dollar sign in the wrong spot. Dollar signs belong at the front of a number because in money, that's where the dollars are found. The cents or change is found in the back. So a lot of times right now, you'll hear people, they'll say, it's $5. Whoops, that looks more like an 8. This is the wrong way to write it. Don't write your money that way. Instead, put the dollar sign first and then the 5 out front because the dollars are in the front. Now, if we paid a cashier a certain amount and we wanted to find the change, all we would have to do is subtract. So in this case, Colden bought a DVD that was priced at $25.85. He gave the cashier 3 $10 bills. So we know that 3 $10 bills is going to be $30. Notice I'm going to write it with that change amount in the decimal form and put in that dollar sign out front. He bought something that was $25.85. So now we're going to subtract. When you subtract with decimals, you subtract the same as if it was whole numbers. We want to make sure we're in the correct place values each time. If the top is smaller than the bottom, we need to borrow from next door. In this case, we got to borrow all the way from the 3. So the 3 becomes a 2. This would become a 10, and then we borrow, so a 9. A 10, we borrow a 9, and then the next one becomes the 10. 10 minus 5 is 5. 9 minus 8 is 1. 9 minus 5 is 4, and 2 minus nothing, 2 minus 2 is nothing, so we don't need to write it. And then we put our dollar sign. So our answer is $4.15. Now, the other part that you're going to be doing in this unit is telling me the least amount of change that you can give to somebody in return. So in this case, I would give $1 bill, and I'm going to give 4 of those. I'm going to give a dime. Now, when we write the dime, because I'm writing it in decimal form, we're going to put that dollar sign out front. Even though that's got $0, we're going to have 1 dime, and then we're going to have 1 nickel. Now, another way that we could write this, instead of how we just wrote it here, is we could do a dollar, a dollar, a dollar, a dollar. And a lot of times dollars, you're going to use a different thing, a dime, and we're going to use a lowercase d there, and then a nickel. So we can write out what kind of change we used also that way. Our next topic is temperature. Now, having some of these benchmarks is a really great idea. In temperature, we have a Fahrenheit scale. That's what we use in the US. And a Celsius scale, that's where they use that pretty much everywhere else besides the US. So water freezes at 32 degrees Fahrenheit and 0 degrees Celsius. Normal body temperature is 98.6 degrees Fahrenheit or 37 degrees Celsius. And water boils at 212 degrees Fahrenheit and 100 degrees Celsius. So if you notice, the Fahrenheit scale has a lot more numbers compared to the Celsius scale. So being able to identify about what temperature something might be in Fahrenheit and in Celsius is a wise thing to keep working on. Now it's time to practice some of the problems at the bottom of your page. Feel free to try these on your own. Pause the video and then resume the video again when you're ready to check your work or if you are stuck and need a little help. All right, welcome back. The first one we're going to look at is fractions that are on a number line. So we're given these fractions in the tiles and we need to place them in the correct ones. So if we look from 0 to 1, I will see that it's broken into 4 parts. So this first one's at 1/4, which means that the 1 would be at 4/4. Now they didn't have that as an option. So 3/3 would also be an object that if I had an object broken into 3 parts and I had all 3 parts of it, I would have 1 whole of it. Because we're still broken into fourths, we could have continued. We would have went 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. So that's how we get 6/4 in the next one. Now again, we're back to thirds again. How many 3s go into 6? The answer is 2. But again, if I were to break it into thirds, I would have had 2 whole shapes of the shaded in if I had 6 pieces out of the 3. Some fractions that are equivalent to 6/6. Well, 6/6 means 1 whole, and that has the same on the top as it does on the bottom, or the same numerator as denominator, which creates a whole. So 3/3 is a whole, 5/5 is a whole, and 4/4 is a whole. A park ranger has 32 feet of fencing. That means it's the perimeter. Fencing would go around an object. What is the greatest area that we can create? This would be one that you probably had to do some trial and error. I'm going to do this over on the side. So let's change my color to white because then you can see it better. Okay. If we had a perimeter of 32 and I wanted to start with maybe ones on the side, that would be 2 out of the 32, which would leave me 30 remaining for the remaining 2 sides. So that would be a 15 and a 15. If I found the area of this, it would be 1 times 15, which would be 15. Okay, we're going to make a slightly taller rectangle and give it 2. So if I have 2 and 2, that would be 4. Take 32 and subtract the 4, I'm left with 28. 28 divided by 2 is 14. So I would have a 14 on top, a 14 on the bottom, and if I multiplied those out, I would get 28. So as you notice, I'm starting to get a bigger area as my shape becomes more of a square. In order to get a square, it would be 32 divided by 4, which would be an 8 by 8. And 8 times 8 is 64 squared feet. And that is our answer. That's the largest area we would get by using that perimeter. Our temperature. This thermometer maybe was a little bit hard to see, but it is at 34 degrees. Notice that on those small tick marks, they're going up by 2s. So you have to pay attention to that. If we are at 2 a.m., it is predicted the temperature will be 16 degrees lower than what it is on that thermometer. We needed to take 34 and minus the 16, and we get 18 degrees at 2 a.m. And don't forget your label of Fahrenheit. Solving the area Again, you wanted to walk your shape, find your missing sides. So we have a missing side of 25 and a missing side of 5. We're finding the area and perimeter of this shape. So if I add up all my outside amounts, I would get my perimeter of 100 feet. And then if I found my area, I would have done 30 times 15 on the top part and 5 times 5 on the bottom part. I could have split mine straight up and down, and then I would have done 20 times 5 and 25 times 15. So either way would have worked, and I would have gotten an answer of 475 squared feet. Keep working on practicing this unit. You can do IXL's The Skill Plan for Grade 3, Unit 5. Also, the Math Activity Center in Math Expressions, the lesson check. Rewatch this video if you need to. Otherwise, good luck.